LZ-1. The first Zeppelin did not look like the beginning of the future. It looked like an enormous metal idea trying to stay alive. On July 2, 1900, Count Ferdinand von Zeppelin's LZ-1 lifted from a floating hangar on Lake Constance. It was not a soft balloon with a basket beneath it. It was a rigid airship, a long aluminum framework filled with gas cells and covered with fabric, designed to keep its shape even when the wind and pressure tried to deform it. The concept was bold. Instead of simply drifting with the sky, LZ-1 would be powered, steerable, and structurally controlled. It was an aircraft shaped less like a bird and more like a building that had somehow escaped the ground. Its first flight lasted only a short time. The airship was underpowered, difficult to control, and far from practical. But that hardly mattered. It had proven that the rigid airship was possible. LZ-1 was weird because it existed before the world had agreed what large aircraft should even look like. It was not yet a passenger ship, not yet a bomber, not yet a symbol of luxury or disaster. It was simply the first serious attempt to turn the sky into an ocean and build a ship large enough to sail through it. It did not perfect the airship. It made every later airship possible. R-101. The British R-101 was built not merely as an aircraft, but as an imperial statement. In the late 1920s, Britain wanted airships that could connect the empire by air. The dream was not a short sightseeing flight. It was a global route system, Britain to India, Britain to Canada, Britain to the far edges of its political world. The R-101 was part of that ambition, a government-built giant intended to prove that Britain could master the airship age. It was enormous. After modifications, it stretched roughly 777 feet long, larger than any British airship before it. Inside, it was meant to carry passengers in comfort across vast distances. Outside, it was a silver machine so large it seemed less flown than launched. But R-101 carried the dangerous weight of expectation. It suffered from design problems, weight issues, and political pressure. The aircraft needed to prove itself, and the schedule gave it little mercy. On October 5, 1930, during its attempted flight to India, R-101 crashed in France near Beauvais and burned. 48 people died, including senior officials involved in Britain's airship program. The disaster effectively ended Britain's great imperial airship dream. R-101 was not weird because it was foolish. It was weird because it was a luxury passenger craft, a national prestige project, and an unfinished engineering argument all at once. It was built to prove that Britain still belonged at the center of the world, and instead proved how dangerous it was when politics began setting the timetable for the sky. USS Akron and USS Macon. The United States Navy looked at the airship and asked a question almost nobody else had asked seriously. What if an airship was not just an aircraft? What if it was an aircraft carrier? USS Akron and USS Macon were massive rigid airships built in the early 1930s. Their job was long-range scouting over the ocean, but their strangest feature was hidden inside the hull, a small internal hangar, and a trapeze system designed to launch and recover tiny biplanes in mid-air. The aircraft, Curtiss F-9C Sparrowhawks, would fly beneath the airship, hook onto the trapeze, and then be pulled inside like fish being lifted into the belly of a metal whale. The system was difficult, dangerous, and astonishingly real. This was not science fiction. It worked. The airships could carry their own scout planes, extending their vision far beyond what the airship alone could see. In theory, they would become the eyes of the fleet, floating high above the ocean while their parasite fighters searched the horizon. The problem was not the idea. The problem was the sky itself. Akron was lost in a storm off the New Jersey coast in 1933, killing 73 people. Macon was damaged in bad weather and crashed off the California coast in 1935, though most of her crew survived. The flying aircraft carrier concept died with them. Akron and Macon were among the strangest war machines ever built because they made complete tactical sense and still belonged to a world that was disappearing. They were aircraft carriers without oceans, hangars without runways, and naval scouts so huge they could be defeated by weather before the enemy ever appeared. Hindenburg. The Hindenburg was not the weirdest airship in appearance, it was the weirdest in contradiction. It was one of the largest aircraft ever flown, over 800 feet long, with dining rooms, passenger cabins, promenades, smoking arrangements, and transatlantic ambition. It was designed to make air travel feel not like survival. Passengers could cross the Atlantic in days instead of a week by ship. They could look down on the ocean from inside a floating hotel. The Hindenburg represented the most polished version of the old airship dream. Not military experiment, not fragile prototype, but luxury transport. And yet this elegant machine was filled with hydrogen. The airship had originally been designed with helium in mind, but Germany could not obtain enough of it from the United States, which controlled major supplies and restricted export. Hydrogen provided lift, but it also carried danger everywhere inside the hull. On May 6, 1937, while landing at Lakehurst, New Jersey, Hindenburg caught fire and was destroyed in less than a minute. 36 people died. The disaster did not kill every airship project overnight, but it shattered public trust in passenger zeppelins. Hindenburg was strange because it combined comfort and catastrophe in the same structure. It had beds, china, windows, mail service, and a skin full of flammable gas. It was the airship dream at its most beautiful and its most vulnerable, and the world remembered the vulnerability. PA-97 Helistat. The PA-97 Helistat looked like an argument between a blimp and 4 helicopters, and somehow both sides lost. Built in the 1980s, it was an experimental heavy-lift aircraft. The idea was simple in theory. Combine the buoyant lift of a helium envelope with the lifting power and control of helicopters. Instead of one aircraft carrying heavy loads by brute force, a blimp would help support the weight, while 4 helicopter units provided thrust and maneuverability. In practice, the machine looked almost impossible. 4 modified Sikorsky helicopter fuselages were attached to a large framework beneath a Navy blimp envelope. The result was a flying structure more than 300 feet long, with rotors spinning from different points beneath the gas bag. It was designed for heavy lift work, including logging and cargo operations in places where conventional transport was difficult. The problem was that combining aircraft does not automatically combine their strengths. Sometimes it combines their weaknesses. On July 1, 1986, during a test at Lakehurst, New Jersey, the Helistat crashed shortly after liftoff. 1 pilot was killed and several others were injured. The project ended immediately. The Helistat was weird because its logic was understandable. Helicopters could lift, airships could float, put them together and perhaps they could lift more. The PA-97 was not 4 helicopters improved by an airship. It was 4 helicopters complicated by 1. CargoLifter CL160. The CargoLifter CL160 was an airship so ambitious that the hangar was completed before the aircraft was. In the 1990s, a German company called CargoLifter imagined a new age of heavy transport. Instead of moving enormous industrial parts by road, rail, or ship, a giant helium airship would pick them up and carry them directly where they needed to go. Power plant equipment, bridge sections, disaster relief modules, oversized machinery, the CL-160 was meant to lift cargo that ordinary aircraft could not handle easily. The planned payload was extraordinary, roughly 160 tons. To build such a machine, CargoLifter constructed one of the largest freestanding hangars in the world at Brandbriesen Airfield in Germany. The building itself became a monument to the dream. Inside it, the company developed prototypes and test systems, but the full CL-160 never flew. The technical and financial problems were enormous. Airships that lift heavy cargo face a brutal physics problem. When they unload weight, they suddenly become too buoyant unless they take on ballast or manage lift in another way. CargoLifter had plans for systems to handle that, but the project ran out of money before the giant airship became real. The company went bankrupt in 2002. The hangar later became the Tropical Islands Resort, a water park inside the shell of an unfinished aviation future. CargoLifter was weird because the most successful part of the airship was the building that was supposed to contain it. It was a project that created a cathedral for a machine that never arrived. Airlander 10. Airlander 10 is what happens when the airship refuses to die and returns wearing modern materials. Originally developed from the HAV 304 for a U.S. Army surveillance program, the aircraft was later brought to Britain and redesigned for civilian use. It is not a traditional Zeppelin and not a normal airplane. It is a hybrid airship using helium buoyancy, aerodynamic lift from its shaped hull, and engine power. Its body is wide, rounded, and flattened in a way that made the public give it an unavoidable nickname, the Flying Bum. The joke stuck because the shape is impossible to ignore. But behind it is a serious idea. Airlander 10 is designed to carry passengers or cargo while using less infrastructure than conventional aircraft. It can operate from flat surfaces, stay airborne for long periods, and potentially serve remote regions, surveillance roles, tourism, or low-emission regional travel. The prototype flew, suffered setbacks, and was later damaged beyond repair after breaking free from its mooring in high winds in 2017. The company has continued working toward production versions, but the machine remains a symbol of both promise and delay. Airlander 10 is weird because it is not a relic, it belongs to the present. It proves that even after the disasters, bankruptcies, jokes, and abandoned hangars, engineers still look at the airship and see something aircraft have not replaced. It may be awkward, it may be slow, it may be difficult to commercialize, but it asks the same question every airship has asked since 1900. What if the sky is not only for speed,